Hello viewers, welcome back to Dexter's Tech Lab. So in this episode we're going to have a look at this piece of test equipment which I've just been given very graciously. So we're going to have a look at this piece of new old video test equipment. So it's going to be very useful in the lab as I continue working on all of the Quantel stuff and trying to fix all that. So this is going to be really useful for that. So what I'm going to do is I'm going to show you the insides of it, how it's all set up, how it works. Once we've done that, I'll power it on and actually show you it working. So what I want to do is thank the person who donated this to the channel very graciously. So this is probably still worth a fair bit of money even today, even though it's actually getting on for a few years old. So thank you very much to the person who donated this. You know who you are. An asset to the community. So what actually is this thing that I keep waffling on about? This is an OmniTek XR. It is an SDI analyzer. So SDI is a digital video interconnect which was used throughout the broadcast industry from the sort of early 90s. And this analyzes pretty much every aspect of it. This dates from about 2008, thereabouts. So this is compatible with HD-SDI, so this does high definition, up to 1080i, I think. So yeah, it's still a format which is in use today, I think. So let me rearrange the camera so you can actually have a look at this and you'll start to understand what we're actually dealing with. Okay, as you can see, it's a black box, one new rack mount chassis. I have been in this, I should say, so I know quite a bit about it already, because when I first got it, it turned out that the hard disk that's in it was going bad, so I had to do a bit of an emergency repair, switch out for an SSD sort of repairs. So if I take the lid off this, you can quickly see that this is a PC. So if I just quickly run over this, obviously there's a load of stuff here. We got a SATA converter here. I had to convert this to an SSD because as I just said, the internal hard disk was starting to fail, so I had to do a bit of a emergency backup and quickly install an SSD into this, so it's going to be reliable for the future. So normally you would have seen a parallel IDE hard disk sat here connected into the port. So usual PC stuff, hard disk, power supply. The actual computer is here. So this is actually a single board computer. It's not like a one new motherboard which has been installed. So this is actually a complete PCI card. It's a bit hard to see from this angle, but there's a PCI riser which basically breaks out the PCI onto another side, which allows the expansion card to plug into it. So the edge connector on the bottom here is actually a PCI slot. So you can see there's quite a bit on the PC board. We have all the usual ports that you could possibly imagine for the period. As I said, this is about 2008. So floppy drive, IDE, USB, serial ports, parallel ports. There is actually a compact flash adapter which is linked in with the IDE ports. You can see we've got a daughter card in the middle here. That is actually a mini AGP graphics card. I think that's an AMD something, I don't know, it's not particularly important. The North Bridge, etc. We've got the system RAM. There's actually only 512 megs in this because, weirdly, for 2008, this is actually running Windows 2000. I had expected it to be running Windows XP, but because that's much more in keeping with this period. But for some reason they were using Windows 2000, so that's what we've got. And the CPU is under this cooler here, so that is an Intel mobile processor. I think it's a Pentium, or along the lines of a Pentium something, Pentium M 1.7 gig, something like that. We've got a load of cooling fans. It's pretty noisy, this thing, unfortunately. These kind of things are always make an absolute racket, unfortunately, so maybe at some point I'll have to look at maybe installing some quieter fans. We've got all the cabling, some of which has been altered and changed and added to because I've added in this SSD. We've got power which runs over onto the PCI riser at the back here, and then OmniTek's technology plugs in on PCI and provides all the processing for doing the video. So all this section here is the bit that's by OmniTek. Now, interestingly, you can actually take this card and plug it into a normal PC and just run the software. So maybe at some point in the future I might look at rehousing this into one of my existing PCs, and it means I won't need to have this one new case. It can all be integrated maybe into my bridge PC, for example. The only thing that might cause a problem is the length of this card. It's quite a long card, so I might not actually have enough room in the case to fit it in, but we'll see. So on the back of that card we have the SDI inputs and outputs. There's two channels, so we've got channel A, channel B, and an output for channel A and channel B. There is also a sync in on this, so just like with most professional broadcast bits of kit, you can insert a sync, which would be like a master clock, which would run around the studio to sync everything together. So there is actually quite a bit going on the OmniTek board. We've got a big FPGA there. I suspect there's probably another one underneath here, but that's all screwed onto a little daughter board, so I'm going to leave that where it is. And there is 1 GB of memory on here, which obviously uses to capture and analyse the actual video signal. In a way, this is essentially like a digital oscilloscope, but quite a specialised one. Right, so let's power this on. Firstly, I'm going to apologise for how loud it is. It's probably going to sound pretty bad here, but there's not much I can do about it, unfortunately. It is as loud as it is. So I've actually got this running through my scaler at the moment, so you can actually get a proper copy of the video. On my BVM, actually technically it's not a BVM, it's a Nikigami, but that is the video output from the OmniTek. So we'll just wait for this to boot up. It won't take very long because it's got a nice SSD in it, so it's pretty quick. Right, that's us all up and running. I've got some video on here. Now, at the moment, that is actually NTSC. So the frame rate is going to be slightly out with what I've got on the camera, so it might be a bit flickery at the moment. And we've got some Quantel content, this is a Laserdisc copy of the Painting with Light program, which was broadcast in the 80s about the Quantel paint box. So we're just going to play that in the background. So as you can see on the OmniTek, we are now up and running. So we've got a full screen view, and this is a waveform monitor at the moment. So if I just come out of here. So as you can see, we've got a live video of the actual signal coming in. But in this case, it's standard definition 525 line video. So as you can see, we're all up and running. We have live video. We've got the video waveforms. So this is all highly configurable. So we can change this between RGB, parade mode. There's just so many options on all of these screens. To give you info. So what actually set up here, we've got a live video, we've got the waveform monitor, we've got the vector scope and the waveform histogram. So the vector scope is showing us the colour information. If I just zoom this up, you can see it's quite a cool view of what we're actually seeing on the screen, and it's actually zoomable as well, so I can actually zoom in here and actually look at this in pretty amazing detail. It's quite a clever bit of hardware this, so I can even zoom in on this screen as well, so it provides some pretty spectacular analysis tools. I mean, I think this would be mostly used for things like colour grading and checking the video in that sort of way. It's not really a signal analysis tool. It's more of a looking at the content. So as you can see, I've also got on this screen here, I've got a crosshair, so that is superimposing that crosshair on, and it's wherever I select it here on the screen. So that's showing here on is effectively the column that I'm on, so I can actually line that up with certain points, and it means I can sort of pinpoint a particular area or a spot that I want to look at. And we also are able to isolate parts of that image. So if I just draw it over here, so that will now only analyse this portion. So it's quite. So there you can see in there the different colours that were on the menu. It's just gone off the screen there. So another mode that we can actually look at is the region of interest. So this gives us a line profile. So this is basically looking at one complete video line. Here, the top one is the luminance. This is the chrominance, blue and chroma red, and that is like a composite version of the signal. As I move through this, you can see where the different colours are going to be coming in, the chroma information. So if we switch over to the full screen view, we've got a load of different preset windows that we can look at. So I can just cycle through these. This will also show the audio information as well, which is embedded in with the SDI signal. So yeah, there's all sorts of things to be looking at. It's not really showing the audio because it's so quiet. The audio levels were really low for some reason when I recorded that. If I switch over to B, I should have my paint box. So that will now switch over to 625 line mode, and have my pen. So you can see on the screen here, this is all fixed obviously because the image isn't changing, but you have the vector scope. Now the vector scope is actually showing you the colours. So you've got yellow, red, magenta, blue, cyan, green. So the way this works is if you had pure red but not very bright, it would be down here, and as it gets brighter, it gets closer and closer to the it's green. It would get closer and closer to the green box, and then at full green, that would be in the actual box. So as more colours appear on the screen, this sort of fills with information, which is kind of cool to see. So pick up green and actually do some painting. You see that this starts to populate as it's going so you're touching on the bit of cyan there, which is around in this area. So there you go. I've hit the green box there, and red. You can also see on here illegal colours, which is colours that are outside the normal YUV gamut. So if I crank the brightness up, sorry, you can see this colour here. It won't come across, but it'll look a bit of a weird colour for you on your recording, but over here on my CRT, that is an epic colour. It's almost fluorescent, so you can see that we're probably getting some red markers on the screen here now. You can just see them up over here, which is where my menu is. I bring my, now you can see I'm affecting that because my cursor is over that spot. So if I swipe off and reset that back, so if I start painting on here with this, it'll be okay with a bit of light pressure, but as I start to generate properly that illegal colour, you can see that it's starting to highlight these areas which are now illegal. So if I bring that off, you can see that on the display here that it's making some pretty weird colours. You know, it's like going this bit here, it's almost white, but on my screen it's got a colour in it. It's all a bit weird. So yeah. So these faded colour bars are quite nice to illustrate the how this works. So red, magenta. If I start, let's get rid of that illegal colour there. So if I start painting black on these, we'll start bringing those colours down in luminance. So quite a nice pattern, that. And then we've just got regular colour bars. So as you can see, it's quite a powerful bit of kit, and it should be extremely useful in the lab going forward. So yeah, thanks again to the nice chap who sent me this. It's going to be extremely useful, I think. Once I go away and learn more about it and what all these numbers actually mean. So yeah, a bit of a learning thing coming up, I think. So thanks very much for watching. I hope you enjoyed this one. If you did, give it a thumbs up, all that good stuff. And I'll see you on the next video. Bye for now.